Hi everyone, my name is Thomas Kim. Today is March 22nd, 2019. This is my second episode about Introduction to Automata Theory and Implementation in C++. In this episode, we will learn finite automata string pattern matching algorithm. This session continues from our previous episode. Please double-click this link. From this episode, click this link and double-click this link to download our previous source code. Click this button, Show in Folder, right-click, please unzip it. Double-click the folder, right-click, rename, Finite Automata String Matching. Now copy the solution, paste it to your working folder. Double-click the folder, copy the folder path, Ctrl+C, start Visual Studio 2017. From File, Open, Solution, paste, backslash, select Finite Automata Solution, open. Solution, click this button. Then open Transition Table, Ctrl F5 to build and run. Okay, this is the previous state of our application. First, I will implement the code, then I will explain the theory. In this book, Introduction to Automata Theory, Language and Computation, in this book, at page 49, you can find extended transition function. At page 49, in this book, you can find extended transition function. It is defined as below. Extended delta q w equals delta extended delta q x a. So delta q a is a transition function. Ext delta q w is an extended transition function. In our previous episode, we created transition table. This is the transition table we created in our previous episode. For example, here I disable this and enable this function, Ctrl F5. This is transition table we built in our previous episode. This is the table 1 0 0 0 1 0 0 0 1 2 0 0 1 2 0 0. This is transition table. Okay, this 0 1 2 3 4 5 6, these are state. I will explain what is transition function, delta, and extended transition function very shortly. Simply put, delta q a is table q a. Okay, q is state this number, a is this number 0 1 2 3. Okay, so this is extended delta. Extended transition function is defined like this recursively. This is recursion, and w is a string. For example, string W A B C D E, then we can represent W X A. X is this part, okay, this part, and X comes from this part, this string. A comes the last character of this string, so A is E in this case. If W is A, B, C, D, E, then X is A, B, C, D, and A is E, the last character. So it is basically something like this. I copy this function once again, then W, I paste it here, W, and I put X, this is X, I put X, then A is E. So this is transition function, extended transition function. This is delta. I will first implement this code, then I will explain what state means, what transition function delta means, what extended transition function means, what transition table means. I will implement the code first, then I will explain the theory behind after implementation. Please remember these things. Delta transition function QA, Q is state, A is a symbol, is table, transition table we built. And extended transition function is defined recursively like this. Okay, now in Visual Studio again, here, double click automata. In talk-play-fun automata.h in this file, template, type name, character type, class DFA, public, using symbol T, character type, using string T, std, basic string, symbol T, using state T, size T, using table T, talk, play, fun, matrix, state T, private, string, and unique. It should be string T, table T, and table. We define a private function, state T delta. It takes a state Q, symbol TS. State T ext delta, state Q, state TQ, string T, I will say W, return. We will implement these two functions very soon. Public, here, DFA, constant string T, string, or table unique create transition table, it should be pattern like this, and table unique. First we can move std move this, and unique std move table unique second. Full pattern exists in string constant string t string. Then we are calling this function like this. Please note that basically delta qs equals table qs or pos this and unique find first of s if pos not equal string t and pos return table q pos. Please note that we have to provide the position. Okay, else return 0. It means symbol s is not in the unique, that is the symbol is outside of range. In this case ext delta qw is defined delta ext delta qx a like this. Okay, this is recursion. This is inside the recursion. We can do like this. If w is empty, it means this is empty string, then return q. Else here we first compute this part like this, or s I say a equals w back the last character, then w pop back, remove the last character, remove last character of w, then or x equals w. Then we are calling this function like this, or r equals ext delta qx. We are calling this part is here. Okay, then or r equals, then we are building this part delta r a. So we are building this part. We first compute the inner side here. We first compute this internal side. Then we compute the external part. These two lines of code can be written in a single line like this. Or R equals delta, and I can put it here, R and A, like this. Okay. Also, please note that we don't need this because we removed one. Okay, we can also fix like this, then W. So because we popped up here. Now here, if R equals, this is the state. Okay, the return value is this state. If this is our transition table. Transition table has 7 rows. 1, 2, 3, 4, 5, 6, 7. 7 rows. And the state, the last state, this is accepting state. Accepting state is 6. So this is dimension 0, 1, 2. These are dimensions of this transition table. So table dim 0 returns 7. 0, 6, it returns 7. Accepting state is 6. Accepting state is, this state is R right now. So we have to test like this. R equals table dim 0 minus 1. We have to test like this. Okay, I will copy this part like this. Okay, then we throw found pattern exception like this. Else return R. Now we have to define this exception, found pattern exception here. In private section, class found pattern exception, std, public, std, exception. We defined exception class. Okay, we throw exception when we found the pattern is in the string. Okay, now at this point try ext delta string. Initially 0 is initial state. This is pattern. In this table, this is 0 state. 0 is initial state, start state. 0, we initially pass 0, start state. Return false. Catch constant found this exception. Then we found return true. Okay, now let's test this class like this here. Void test string matching DFA talk platform DFA. We provide the pattern here, std string pattern I will copy this part. Then we provide pattern here. Now stream std bool alpha stream does the pattern pattern PATL pattern exists in, we create a string here, std string a b c d e f a b c a b y a b c a b y a b c a b y. Okay, then we call DFA function like this. Pattern exists in string. We provide a string. We can just say W. And now we build and run. We have to fix it W. Now we call this function. I copied, paste it here, Control F5. It should be M table. Like this. Control F5. This is M5. This M table. Control F5. Pattern ABC ABY exists in string true. Here. Now we can test more strings like this. std string. Or we can make it a loop. Here. While true. std stream input pattern. std cin pattern. Stream input string. std cin. Then we can try multiple times like this. Input pattern ABC. Input string. So ABC exists in ABSF blah blah false. The same pattern ASDS ABC ABC exists in pattern true because ABC exists here. ABC true, AB false. So you can try it. Control C. Suppose we want to test if a string pattern ABC ABY exists in a string W ABCDEF ABC ABY. Then we have to match ABC ABY. To match this string, before we match this string, we have to match this string ABC AB. Before we match ABC AB, we have to match ABCA. Before we match ABCA, we have to match ABC. Before we match ABC, we have to match AB. Before we match AB, we have to match A. Initially, our string is empty. Okay? So we collect these into set like this, and we denote this set Q. So if we want to find this pattern in this string, this is final stage, final state, we have to find ABC ABY pattern in this string. To find this pattern, we have to find ABC AB, this pattern first. Before we find this pattern, we have to find this pattern. Before we find this pattern, we have to find this pattern. Before we find AB, we have to find pattern A. Initially, we start with empty string. Okay? Now let's think about this. Delta is a transition function. If initially this is string and we see an A, then the return value becomes A. So from empty string, we are appending character A, then result is a string. Okay? Now let's try once again. Delta, initially empty string, we try with B, then it gives B. Okay, now let's try again. Delta, with the empty string, we append the character C, then it gives string C. And the delta, empty string, we append Y, then it gives Y, like this. I copy this same string once again, pasted. Please note that we now copy this part once again. I pasted, then I label it to 0, then 1. Then I denote this part 2. Then I denote this part 3. Then I denote this part 4. Then I denote this part 5. And finally, this is 6. So each state, these are state 3, state 4, state 5, state 6. State 0 means empty string. State 1 means the first character A of this pattern. State 2 means two character AB is seen in this pattern. State 3 means we have seen ABC, 3 characters. So each state in Q represents the string pattern we have seen so far. So this is state A. A amounts to this. So it is denoted to 1. Like this. Now let's see this case B. There is no state B. There is no such thing B. There is no such state in this Q. So it is 0. We make it empty string. And empty string is 0. We denote it 0. So there is no state C string here. So we denote it to 0. Okay? And in this case, there is no state Y. So we denote it 0. Also note that empty string state is 0. Okay, empty string is state is 0. Empty string is 0. So I modify like this. 0, 0, 0. Okay, from this pattern, we make a unique string. Unique will be ABCY. Okay, instead of A, we place 0. Its index is 0. Instead of B, we can place this 0, 1. Instead of C, from C, we can place 1, 2, 3. Like this. 2, 2. 0, 1, 2. Instead of Y, we can put 0, 1, 2, 3. So it becomes 3. Okay. Now let's think about this value with this table. I will copy this table for your reference. I copied and pasted it here for your reference. Now let's compare this value. 0 is state. Q. State. This is state. 0, 0, 0. 0, 0 means 1. This is 1. 0, 1. 0, 1. This is B. 0, 1. This is 0. Here 0, 0, C. C 2, 0, 2 is 0. Delta 0, state 0, 3. Y is 0. So the contents, the element of this table, this is state table, transition table. So delta Q, I say QS is table QS. Okay, where Q is state, S is the index of unique ABCY character position. Okay, I hope you understand what is delta. Now let's try with the second case. Now let's try with this case. Delta A. Now this means A plus A. Then we shrink 1 like this. Okay. Now let's try another one. I copy once again. Paste. B, then it becomes AB. Okay, now I copy once again AC, it becomes AC. Okay, now I copy once again AY, then it becomes AY. Now let's think about this. I will copy this once again. Here A, string A is A's state is 1. So I modify it 1. This is 1. This is 1. This is 1. Okay? And A is 0. A's index is 0. B is 1. C is 2. Y is 3. So it becomes 0, 1, 2, 3. Okay, this is state. State of A is 1. This becomes 1. And AB has state 2. It becomes 2. Okay, here AC, there is no AC. There is no AC in the state. So it is 0. No state, it means 0. 3. In case of AY, there is no state AY here. In the Q, in the set Q, there is no AY. So it becomes 0. Okay, now I arrange it like this. Now let's compare 1, 0. So 1, 0 is 1. Okay, now here 1, 1. 1, 1 is 2. 1, 1 is 2. 1, 2. 1, 2 is 0. 0. 1, 3. 1, 3 is 0. Okay, so this is the conclusion is that the transition function delta Q A equals transition table Q S. S is the position of a symbol A in unique abcdy. Please understand this concept. Okay, now, and another point we need to understand is in delta Q A, Q is a state in Q. Q is represented like this or this. Okay, state Q represents a sequence of inputs, input string. In the transition function delta Q A equals table Q S. A is a symbol in the string unique abcdy, and S is the position of A in unique abcdy. What if the symbol A does not exist in abcdy? For example, delta Q X. The symbol X does not exist in abcdy. The position of X is S and S is not defined. That is out of range. In such case, delta Q X is 0. Start state. Now let's see our code about delta. In this function, transition function delta takes a state Q and a symbol S. The position of S, it means if it exists. Okay? If the position is not found, the index or POS does not exist in unique, then we return 0. Okay, I hope you understand this part of code. That's why we are returning 0 when the X, this X symbol does not exist in unique. If it exists, if X exists in the unique, if X exists in the symbol, unique symbol, then we can return the table like this. Now let's move on to extended transition function. Extended transition function is defined ext delta takes a state Q and string W. Q is a state in Q, W is a string. For example, A, B, C, D, E, F, A, B, C, A, B, Y. Let's think about W is an empty string. So ext delta Q empty string. What will be its state? Q is a state in Q. So Q is defined like this, a state in Q. Or let's take A. ext delta empty. Okay? In this case, empty string as a state is 0. So it means ext delta 0 empty string. If we append two empty string, the result is empty string. Okay? ext delta A empty string. Let's think about this. ext delta string A as state in Q is 1. Then it becomes 1 empty string. Or if we add these two, A plus empty string, A concatenate empty string, this is A. Okay? A is as a state 1. Empty string as a state is 0. Now let's try another one. ext delta AB empty string. ext delta AB as a state is 2. Then it becomes 2 and empty string. This we are concatenating two strings together. AB concatenating empty string. This is AB. AB as a state, it means 2. Okay? So ext delta for any state Q empty string is Q. Okay? So this point is important. Now let's examine our code. This is extended transition function. when the string W, this string W, this is W, is empty string, then we return Q. Okay, this part amounts to this part. If W is not empty, then ext delta Q W is defined delta ext delta Q X A, where W equals X A is the last symbol in W, X is the leading part of the string of W except the last symbol A. For example, if Q is 3 or ABC, W is ABY, WXA means ABY, X equals AB, A equals Y. If we substitute X and A to this equation, to this definition, I copy and pasted it here, then W ABY X AB, then A is Y. Now let's think about this. We apply the same rule once again. This rule once again. Delta ext delta Q A B. Now we apply the same rule once again. I copy this part. Delta ext delta Q empty string A. Please note that to calculate this equation, this function calls recursively this part. Then this function calls this part. Then we need another one. I copy this here. This is empty string, so we apply this rule. Then it becomes Q. Now let's go back in reverse. If we put Q in this place, then it becomes, this is Q, like this. Then it becomes delta. Please note that Q is 3. Q is 3 ABC. Right? Q is ABC. A. Then we concatenate ABCA. It becomes ABCA is 4. It becomes state 4. Now in this equation, since this is 4, we apply 4 here. This is delta. 4 is abca. 4 is abca here. And b, if we concatenate abcab, this is 5 as a state. Okay, now we apply once again here. I copied this state. This state is 5. Delta 5 as a state, as a string is abcb. Why? If we concatenate, it becomes abc aby. This is 6. So ext delta, we initially started q is 3, aby. Please note this part. Then 6. So extended transition function ext delta q w means ext delta abc aby, abc aby, abc aby. Extended transition function concatenates two strings, whereas transition function concatenates one string or state with a symbol. So in this recursive part, let's compare this part with our code here. A is the last character of W. A is the last character of W, and this value X is the leading part of W. We remove the last part here, the last character here, then we can set X. Because we removed the last character, we strictly applied this rule, extended transition function. So using transition function delta and extended transition function, we implemented pattern exists in string function. In this episode, we learned about transition function and extended transition function for DFA or Deterministic Finite Automata. In some future session, I will give you formal definition of Deterministic Finite Automata. And in next episode, we will learn about non-deterministic finite automata. Please subscribe to my YouTube channel. Thank you for watching.